Hey, what's up everyone? This is Mr. Sim Engineering bringing you the new 2022 version of my AWR microwave office tutorial. This will be replacing the version 14 series that was done back in 2019, and we will be covering version 16 here. So we're looking at a blank project in AWR microwave office. And if we look to the left here, we are looking at what is called the project pane. It's technically made up of 3 tabs, each with its own purpose, and we'll cover those as we get to them. And so the first thing that we're going to do here is we're going to look here at project options. You can either right click and do edit, or you can double click on it, which opens up this project options area. And so we're going to select single point. This basically just means that we're going to be simulating one frequency, and we're going to set that to 2.4 gigahertz. You can always check your data entry units down here to make sure that they are correct. Next, we're going to hit apply. Then we're going to go here to the tab called global units. We're going to hit edit units. It's going to open up this window. We're going to change frequency to gigahertz and hit OK, and then OK. So now we are basically set up to simulate the project default of 2.4 gigahertz and to display all units in our graphs and stuff like that in gigahertz. So the next thing we're going to do is we're going to go back to the project pane to circuit schematics. We're going to right click and do new schematic. It's going to pop up this little window here. We're going to call it terminated line. And that's going to create a new schematic that we're going to be working with here. The next thing we're going to do is we're going to introduce the elements pane. So here where the project pane is, if we look to the bottom, there's 3 tabs. One of them is called elements. You're going to click on that. Because we have a circuit open, it's going to expand the listing for circuit elements, and it's going to collapse system blocks and 3D EM elements. We're going to discuss those in the future. Specifically here, we're going to want to add some things for doing our simulation. Specifically, we're terminating a transmission line, so we're going to expand transmission lines. I'm going to select phase, and then we're going to select T-line, or T-lin, T-L-I-N, which is transmission line. Another way to add elements is up here in the toolbar. We have a little button that says ELE. You can click on that. It opens up this big window here. Let's actually shrink that a little bit. And then what you can do is you can go to name, click under name here, and type in the name of your component, or if you know kind of what you're looking for, you can type in a word into the description field. So for example, what we're looking for here is ZFREQ, which is complex resistor with a table specification. I know that sounds, complicated, but it's really not. We're just going to click on that and hit OK, which is going to drop that into our circuit. So then what you can do is you can just kind of connect these things in 2 different ways. But before we do that, let's go ahead and drop in a port. You do that up here. Just click on that, and then just click inside of your design. So it drops in a port, automatically names it port 1, and gives it the default RF characteristic impedance of 50 ohms. So from there, we need to connect all of these things. So we're going to go ahead and click here, click there, click here, click there. We also need a ground, so we can look up here, grab that, drop it down here. And another way to connect these things is just to overlap the 2 X's. So if I click and drag and overlap them, it'll connect them. And then you can also select by clicking and dragging, and then you can move things around. So for example, I'm going to select the port, move it over. You can move things around, such as the ID and the identifying information can be moved around as well. You can always right click, and you can disable things, rotate things, flip things, freeze things, etc. You can, of course, Control C to copy, click somewhere else, Control V to paste. And while you're placing, you can right click to rotate, let's say you've already dropped in a component and you want to rotate that component, you can right click and hit rotate. It changes your cursor. So if you look at your cursor, it's different. So what you're going to do is you're going to click, drag, and pull. So what that does is it basically sets the center of where it is that you're going to be, like about what point are you rotating, and then you can literally just rotate about that point. And you can set that point wherever you like. So for example, let's say I want to rotate 90 degrees, right, about the point. So I go down 90 degrees, and then obviously the component flips to the top there, for example. Another thing you can do is, if we look here at the T-line, it has a little line here through the line. This signifies port 1. What you can do is you can do a flip, for example. You see how the cursor changes. You can click, drag, right? And that basically sets the axis about which you're going to be flipping. So you can kind of see already that the little slash has moved down because port 1 is now on the bottom instead of on the top. And we can, flip that back, for example. You can also flip about a different axis. So you can do a vertical and flip it around that vertical. And then, of course, there's always the option of selecting something and hitting delete on your keyboard, and it will delete it. So anyways, now let's actually work with our circuit here. By the way, if you want to pan around the space, you can hold down the middle mouse button, the scroll wheel. You can press down on it, and you can pan around the workspace. If you scroll, you'll scroll up and down. If you hold Control and scroll, you can zoom in. If you hold Shift and scroll, you'll go left to right. Anyways, now let's set up some of the things for our project. So the first thing that we're going to do is let's set up the transmission line itself for 50 ohms. And it's going to be 180 degrees. And we're going to set the center frequency to 2.4 gigahertz. Then we're going to change the complex resistance here, the complex impedance. We're going to change the frequency of operation to 2.4. And we're going to go ahead and set the real part to 75 and the imaginary part to 25. So then, if you're enjoying the tutorial so far, please do go ahead and subscribe and leave a like and a comment. And let's get back to work. So the next thing that we're going to do here is we're going to create a graph. So we're going to go to the left here. We're in the elements pane, go to the bottom, switch back to the project pane. And then we're looking here at graph up top here. You can right click there and do new graph. We're going to select Smith chart. And we're going to call this input impedance. And you're going to hit create. This creates a new graph. Now there's two ways to add measurements. You can go to the left into the project pane and right click on the actual graph itself and do add measurement. Or if you're already looking at the graph and you want to add a measurement, you can just right click on the graph itself and do add new measurement. This will bring up the measurements window. And specifically what we're looking for is under linear here in measurement type, port parameters, and then under measurement, select S parameter. The data source is going to be the terminated line schematic or circuit. We want to go to port, from port, obviously 1, 1. We only have one port. And we're going to sweep the frequencies using and use them for the x-axis. And of course, we only have one frequency, so it says n is equal to 1. The simulator will be left default. Configuration will be left default. We want the complex representation because obviously we're looking at a Smith chart here. And then you can either hit OK or you can hit Add. If you hit Add, it will not close the window. It allows you to add more measurements. If you hit OK, it'll just add that one measurement and close the window. Finally, we're going to simulate by going up top here and clicking on the Simulate button. Another way to do this is to go to Simulate here in the menu and hit Analyze or press F8. So then that puts our point. You can actually click on the point and see where the point is. So it says R 1.5, X is equal to 0.5. Obviously, this is normalized impedance. It is normalizing to the port impedance that we set before. So if we go back to the circuit, the port impedance is 50. So that's going to be 75 divided by 50 is 1.5. 25 divided by 50 is 0.5. So therefore, what we're looking at here is 1.5 plus J 0.5. And the reason why that is because as we know from microwave engineering, microwave circuits, right, we have a half lambda feeding line here of an equivalent impedance to the port. So this feeding line is 50 ohms, it's 180 degrees. So it basically just pulls this load impedance to the port. So the input impedance that we're looking at in here, if I could draw, I think I can draw. Can you draw? No, you can't doodle. You can't doodle, but I think you can do an arrow. So let's do an arrow, right? Yeah, let's do that, right? Oh. So, hey, I'm figuring stuff out mid-tutorial, right? So if we're looking here, right, at the input impedance, what we're looking at when you have that half lambda line with the same characteristic impedance as the port is we're basically just looking at that load impedance as, again, 1.5 plus J 0.5. So that's what we're looking at here. So the next thing that we can do is, for example, let's change the load impedance to 100. And then let's change the imaginary impedance or the imaginary component of the impedance. Let's change that to 0. And then we can change the impedance of our line here to 70.71, right? That comes from the equation that if you're doing a quarter wave transformer, it's the square root of the characteristic impedance of the port in question and times the real part of the load impedance, right? And so we can change the electrical length here to 90 degrees because that's quarter lambda, right? Quarter wave. And then what we should see here is this should move to the center here, which it does, right? So now from there, moving forward, right? Let's, for example, let's add an imaginary part here. Let's say 30, right? If I simulate, again, you can see that the point moves around as we would expect from changing the different impedances and stuff like that. Obviously, the things change. Now, let's go back to the circuit and let's right-click on this line here, and you can hit Properties, or another option is you can double-click on it. It opens up the Properties window. And specifically, what we're going to look at here is this tuning column, and we're going to hit Tune on Z0 and Tune on the electrical length. And we're going to hit OK. You'll notice how these things turn blue. We're going to go back to the graph. And then what you're going to do is you're going to come up here and you're going to select this little tuning button. It's going to open up the tuning window. What this allows you to do is it allows you to tune the values live and rerun the simulation every single time you select a value. Let me take a sip of coffee here. Okay, now let's try to figure out what electrical length and impedance we might need to get back to the characteristic impedance of 50 ohms that we're looking for that port impedance. So if we change the impedance of the feed line, we can see the point moving left to right. Okay. If we change the electrical length, we can see the point moving kind of about a circle, right? This is typically what we expect, right? So I want to, you see, I'm kind of almost there, right? And by the way, you can do the same thing here. You can go Control and scroll and zoom in. And then you can, for example, right click and add a marker. Just click on that, right? Which adds a marker to the actual value there. And then I can go back and just start playing with that a little bit. And that's pretty close. That's 0.99 and 0.00. So in order to match my complex impedance here of 100 plus J30 to 50 ohms, we would need to, again, you can read the values off of our little window here. You would have to create a line that is 76.71 ohms with an electrical length of 111 degrees, whatever that is in the lambdas. And if you put those things in series, then that will match your input impedance here, the black arrow that we're looking at. That'll match your input impedance to 50 ohms. So therefore, you have the port at 50 ohms and the terminated line at 50 ohms as well. So anyways, this brings us to the end of part 1. Remember to leave any questions that you have below, like the video, subscribe. And in part 2, we're going to start designing a Wilkinson power divider, simulating the Wilkinson power divider, and we're going to be working with that and kind of building the rest of the tutorial series from there using that Wilkinson power divider. So thanks to everyone, and please take care, and I hope to see you next time at part 2.